All right, hey, what's going on, guys? Daniel from Neutron Tutoring here. Today we're going to be going over some SAT math topics. So the first one we're going to be looking at here is systems of equations, and we're going to take a look at this problem number 11. So we can see we have two equations. B is equal to 2.35 plus 0.25x, and C is equal to 1.75 plus 0.4x. In the equations above, B and C represent the price per pound, so dollars per pound, of beef and chicken, respectively, X weeks after July 1st during the last summer. What was the price per pound of beef when it was equal to the price per pound of chicken? So the question here is basically, what is B equal to when it's equal to C? Is another way to interpret that, right? What are they going to be equal to when they're equal? Well, in order to do that, we have to say 2.35 plus 0.25x, which is the equation for B, is equal to the equation for C, which is 1.75 plus 0.40x. So we can solve this pretty easily by subtracting the 0.25x from both sides and also subtracting the 1.75 from both sides. And what we'll get is basically this will cancel out and this will cancel out, and we'll have effectively moved the x terms to the right-hand side. So we'll get 0.2 minus 0.05, which would be 0.15x. And on the left-hand side, we would have 0.25 plus 0.35, which would be 0.5 plus 0.1, so it would be 0.6. So we'll get 0.6 dividing by 0.15 on both sides will give us what x is equal to. Now, we'll plug that into a calculator, and we get 4. So let's notice, though, that we solved for x and not what we originally asked for, right? We're asked for what is b equal to when b equals c. So now we're going to take that x value and plug it back into the equation, 2.35 plus 0.25 times 4. And if you remember that a quarter times 4 adds up to $1, then this is basically 1. So we have 3.35, which is the answer choice D. Make sure that when you're solving for x, you actually determine the answer, which in this case is what is b equal to, not what is x equal to. Okay, moving along, we have linear inequalities. So here we have which of the following numbers is not a solution to the inequality 3x minus 5 is greater than or equal to 4x minus 3. Now, some of you may be tempted to just plug in each of these answer choices, but that's going to be very time consuming. So in order to solve this equation, we're going to take 3x minus 5 is greater than or equal to 4x minus 3, and we're going to solve it for what x has to be greater than or equal to. What I mean by that is we're going to add 5 to both sides, and we're going to subtract 3x from both sides. So we get 0 is greater than or equal to 1x plus 2. Now, basically what we just did is we just did algebra on an inequality, which is totally fine. The next thing we can do is we can actually subtract this 2 back over, which to some of you might seem a little redundant, but what I get here is negative 2 has to be greater than or equal to x. And if we look, there's a couple options, but let's draw a number line like this and say this is 0 and this is negative 2. And what we're saying is negative 2 has to be bigger than or equal to x. So basically x has to be to the left of negative 2. Now, there's some options, negative 3 and negative 5. And it looks like actually there's multiple options here. Oh, and that's fine because we need to read the question and notice we're looking for which of these is not a solution. So basically all of these are solutions because those would account for x being less than negative 2, right? I could turn this around and say x is less than or equal to negative 2. That's saying the same thing. But the only option choice that isn't less than negative 2 would be A, which is negative 1. So we're going to select A. Okay, the next topic we have here is graphing linear equations. So here we're going to actually read the question and then draw a little graph for ourselves. It says a line in the xy plane passes through the origin. So here's our xy plane. We're actually going to draw that. When you're taking the SAT, use a piece of scratch paper to draw this xy plane if you don't have it for the question. So we know there's a line that passes through the origin, which would be the place where the x and y axis cross, and has a slope of 1/7. So that would look something like this, right? And basically we know y is equal to mx plus b for any line, And in this case, they told us the slope is 1/7. So we know y is equal to 1/7 x plus b, where b is the y-intercept. But in this case, the y-intercept is happening at the origin, which means that b is equal to 0 because the height of the origin is 0. So y is just equal to 1/7 x. Which of the following points lies on the line? So the question is, which of these options work with this equation? So we can try a couple options out. For the first one, would be saying 7 is equal to 1/7 times 0, because we're just going to plug in the y and the x value that are in the given point. Remember, every point is x comma y, so don't switch that around. This is obviously not true though, so A is not our choice. The next one is 7 is equal to 1/7 times 1, but that's also not going to work because 7 is not 1/7, so we're going to cross that out. We can try 7 is equal to 1/7 times 7. This is for option choice C here. But if you look at the right-hand side, 7 times 1/7 is 1, and 7 is not equal to 1. So it's actually not that one either, which means it has to be this one. 2 is equal to 1/7 times 14, plugging in x and y. And what we get is something that's actually true because 14 divided by 7, or 1/7 times 14, is equal to 2. So it's option choice D. Okay, the next topic here is functions, right? So normally we see this as like f of x is equal to y, and that's equal to like x squared plus 2 or something like that. Now in this problem, that's not what we have. We have g of x, and strangely, g of x is equal to ax squared plus 24, where a is some constant, meaning it's just a number, but we don't know what that number is, which is a little bit different than a variable, which could be any number, right? So a is a specific number, we just don't know what that value is. Okay, we know that g of 4 is equal to 8, which means when you plug in x is equal to 4, the result is 8, meaning the result of this equation is 8. And we're asked, what is the value of g of negative 4? So we want to know what g of negative 4 would be, which means we need to find a, right? If we knew what a was, we could plug in negative 4 for x here and solve. But if we don't know a, we don't know that number that it's going to be. So we need to plug in first that g of 4, which is equal to 8, is going to be a times 4 squared plus 24. And actually, some of you might notice that if we plugged in negative 4 here, which is what we're going to want to do in a second, we would actually get the same thing because negative 4 squared is going to be the same thing as positive 4 squared, right? 4 squared is equal to 16, and negative 4 squared is also equal to 16. So whatever a is, we can actually not even find what a is equal to because we know that this will be 16a plus 24 will be the same thing for positive or negative 4, and so we know that this is going to be 8. Now, if you didn't notice that, you could go ahead and solve it the way we originally thought we were going to, but we're just going to go ahead and select positive 8 here and move on to the next question. For nonlinear expressions, we're going to take a look at this problem. If ax plus 2 times bx plus 7 is equal to 15x squared plus cx plus 14 for all values of x, and a plus b equals 8, what are the two possible values for c? So this would be also known as like a quadratic problem. However, this one's particularly difficult. So if this one doesn't make sense, make sure to review the quadratic section coming up. Here, the way we're going to solve this is we're going to write down our system of equations. A plus b equals 8, and ax plus 2 times bx plus 7 is equal to 15x squared plus cx plus 14. Now, if we expand the left-hand side, remembering to FOIL, we're going to get ax times bx plus 2bx plus 7ax plus 14 is equal to all this stuff. And because this is equal, we can actually take out the parts that have, for example, oops, I forgot a square there, the ax squared term, meaning this abx squared is going to be the same thing as this 15x squared. So we can say abx squared is going to be the same thing as 15x squared. Because of this equal sign here, we're allowed to do this. And if that doesn't make sense, please review quadratics. So we can say a times b must be equal to 15. And we also know that in the middle here we have 2b plus 7a all times x if we sort of rewrite that. And we know that that's going to be the same thing as cx, right? So we can also write 2b plus 7a is equal to c. We were also told that a plus b, in the words over here, we were told that a plus b equals 8. So basically, we want to find what 2b plus 7a is because that's what we're looking for, right? We're looking for c. But we also have these two equations that a times b equals 15 and a plus b equals 8. So you could go ahead and solve that by doing algebra, but if you think about it for a second, what we're really looking for is numbers that when multiplied equal to 15, but when added equal to 8. So for example, we could try 1 times 15, but those don't add to 8, so those aren't our numbers. The next one that you could think of would be 3 times 5, and actually, that would add to 8. So we could say a is 3 and b is equal to 5. And if that's the case, then c would be equal to 2 times 3, or sorry, 2 times 5, because that's the one we said it was b, plus 7 times 3, which would be 10 plus 21, which would be 31. And if you flip these around, for example, you may be thinking, well, what if I said a was 5 and b was 3? That would give you the other option choice in our answer, which is, whoops, crossed it out there. 31 and 41 would be the other way around. Okay, so that was kind of difficult. Feel free to rewind and look at how I did that. Pay close attention to the equations we got here, which is a times b equals 15, a plus b equals 8, and then 2b plus 7a equals c. Okay, moving on here, we have nonlinear graphs. So we're going to look at this problem, which has this graph, and that again is a quadratic equation. So for the SAT, you really want to pay close attention to quadratic equations because a lot of the problems deal with them, especially the harder problems. So which of the following is an equivalent form of the equation of the graph shown in the xy plane above, from which of the coordinates of vertex A can be identified as constants in the equation? So what we're talking about is there's this vertex point on the quadratic, which is either the bottom or the top of the quadratic, depending on if it's facing up or down. The vertex will be the minimum or maximum. And what we're looking for is an equation that's the same as this equation, but we can read the vertex from the equation. And what they're referring to here, they're referring to vertex form. So vertex form is going to look like k, or rather, you can use any letter you want, but usually k goes somewhere else, a times x minus k squared plus h. So this would be y is equal to a times x minus k squared plus h. That's known as vertex form. So this equation is not in vertex form. X squared minus 2x minus 15 is in what is known as standard form. And if we look, these two options A and B, now we're using process of elimination. These two options A and B are not in vertex form. They're what's known as factored form, x minus h times x minus k. That would be considered factored form. So we're going to cross those out. And if we look at the other two options, C looks close to vertex form, but if you look closely, there's no squared, and that would make it not vertex form. So this one down here is the only option that's in vertex form. And if we look, we can actually identify the vertex from the fact that k comma h is going to be the vertex in vertex form if you have it written like this. So from this option choice D, 1 comma 16, or sorry, negative 16 would be the vertex. And if we look at this point, it does appear to be at 1 comma negative 16. So D is the correct option. There's one other form that we didn't really look at in this problem. I mentioned it briefly over here, factored form. But you want to know all three of these formats for the SAT when it comes to dealing with quadratics. All right. Next topic we're going to look at here is rates/ratios. So this problem says Wyatt can husk at least 12 dozen ears of corn per hour. So 12 ears per hour. 12 dozen, actually. So that would be 12 times 12 ears, because 12 dozen would be 12 times 12. So that's 144. We can write that 144 ears of corn per hour. And next to it, I'm just putting the units. I'm actually going to put those in square brackets, which can be helpful to keep numbers not getting tangled up with the units. And it says at most 18 ears, 18 dozen ears of corn per hour. So it's actually, this is a minimum. So it's between 144, and I'll say E is between 144 and 18 times 12 ears per hour. So what I just did is I made an inequality, right? E is the amount of ears of corn per hour that this person Y is husking. And it says, based on this information, what's a possible amount of time? So we're looking for time T in hours that it could take Y to husk 72 dozen ears of corn. So what we're basically looking for is if we know that he's going to do 72 dozen ears of corn, then basically what we're saying is if we multiply this times T and this times T, then this number here would be 72 dozen. And actually, to make my math easier, I'm just going to say that actually these are in dozens. So it's 12 a minimum, 12 dozen ears, and 18 dozen ears. So we can say 72 over 12 would be equal to a certain number, and then 72 over 18 would be the upper end of hours it would take. So let's plug that into a calculator real quick. Okay, so we plugged it into a calculator and we got 6 and 4, which means that if they were going at the slow rate, it would take them 6 hours, and if they're going at the fast rate, it would take them 4 hours. So one possible amount of time in hours that it could take this person would be between 6 and 4. So we would just say 5 would be reasonable. Now, you could say 6 or 4 or 5, but just because these numbers were nicely spaced apart, I'm going to use 5 hours as the answer choice I would fill in. Okay, another topic we're going to look at here is scatter plots. So scatter plots are pretty common on the SAT, and you're usually going to get at least one question about them. So here we have a graph that is a scatter plot, and it looks like swimming time versus heart rate. So we have swimming time on the x-axis, so this is time, and this is heart rate, let's just call it R. And it goes from 33 to 37 on the x-axis, and 120 to 160 on the y-axis. Notice it's not starting at 0 on either of the axes. This point, in other words, is not the origin, it's some other point. So let's read the context now. It says Michael swam 2,000 yards on each of 18 days. So we have 2,000 yards for 18 days. The scatter plot above shows him his swim time for the corresponding days and each heart rate after each swim. The line of best fit for the data is also shown. For the swim that took 34 minutes, Michael's actual heart rate was about how many beats per minute less than the rate predicted by the line of best fit. Okay, there's a lot going on in there. So what's asking us for is based for the day where it took 34 minutes, which would be this day, because that's at the 34 minutes, there's this one little dot there. And let's actually, I'm going to move this and make this bigger so we can see it. This day, it took 34 minutes for the swim. And the question is asking, how many beats per minute less than the rate predicted by the line of best fit was Michael's actual heart rate, right? So we're looking for the minutes less than predicted, right? Because this line here on this graph is predicting the heart rate, but it's not the actual heart rate. Those are the data points, each dot in this graph. So we can see here that it looks like it's one little block down from the predicted. So now the question is, well, what are those blocks? And one way to do this is to sort of count how many there are between some known numbers. So here it goes 120 to 130, and there's 1, 2, 3, 4, 5 blocks. So it looks like 10 is the difference between the heart rates at this point and this point, and there's 5 blocks. So each block is 2 beats per minute. So that's to say the distance here is 2 beats per minute, different than the predicted, right? The data point was 2 beats per minute lower than the line of best fit on that particular day where he swam for the 34 minutes. So our answer choice here would be B. Okay. Another topic we see on the SAT is two-way tables. So here, I'm actually going to go ahead and make this one bigger as well so we can read it. It says a group of 10th grade students responded to a survey that asked which math course they were currently enrolled. The survey data were broken down as shown in the table. So we have gender and we have which course they're in. The other thing you're going to see with these two-way tables is the total columns, which is really handy. And if they're not there, you should usually make them yourself. Okay, which of the following categories accounts for approximately 19% of all the survey respondents? So out of this total survey respondents, which is 310 people, the question is, which of these categories is 19% of the 310? So what we can do is figure out what the number is in each of these groups, and then we can divide that by 310 and see what the percentage is. So for females taking geometry, we have the female column and the the female row and the geometry column, so that's 53. So we're going to do 53 divided by 310 and see if that equals to 19. And to save some time, I'll just write down all of these real quick. Okay, so I went ahead and I wrote down each of the fractions we're computing, and you can see I color-coded each one to the group that I am dividing by the total. So again, there's 53 out of 310 females taking geometry out of the total people who participated in the survey. But that only gives us 0.17, which is 17.09%, right? Similarly, females taking algebra 2 is only 20%. And males taking geometry is the one we're looking for, which is 19.03%, but usually that extra little bit doesn't matter. And we can confirm that by getting the last one. Males taking algebra was only 14%, so it's going to be males taking geometry, option choice C here. That's the one we're looking for. Okay, another topic that we're going to be looking at is trigonometry. So it tells us in a right triangle, one angle measures x, where sine of x is 4/5. What's cosine of 90 minus x? So what we can see here is if we draw a triangle and label one of the angles x, that the sine of x, if we write down SOHCAHTOA, sine of some angle theta is equal to opposite over hypotenuse from the O and the H here. So what we're saying is the ratio of the opposite over the hypotenuse, which would be this one, because it's opposite the angle, to the hypotenuse, which would be the longest side, would be 4/5. So this would be 4 and this would be 5. And we're asked, what is the cosine of 90 minus x? Basically, 90 minus x is going to be this other angle here, because we know in a right triangle everything adds up to 180. So if I call this one, let's say it's called y, the other angle in the triangle, we can say x plus y plus 90 is equal to 180. Another way to say it is, if we wanted to know what 90 minus x was, we could say that, well, we know that x plus y is equal to 90 from this equation. So 90 minus x would be the same thing as 90 minus y. Or in other words, we just know that 90 minus x is equal to y. So if you look at that closely, you just get positive y from that equation. So 90 minus x is the same thing in a right triangle as the other angle y. So we're basically asking what's the cosine of y here, meaning the angle in the right triangle that's not x. Well, cosine from SOHCAHTOA is adjacent over hypotenuse, which that would be according to y, this side that was the opposite is now the adjacent because it's next to the y. And the hypotenuse is still the hypotenuse. So this would also be 4/5. Or in general, we know that the sine of x is equal to the cosine of 90 minus x. That's just a fact for right triangles. So basically, they already told us the answer in the question. It's just 4/5. Okay, another topic we need to talk about is similar triangles. So in this question we have, it looks like a lake and there's two triangles. So it says a summer camp counselor wants to find a length x in feet across a lake as represented in the sketch. The lengths represented by AB and EB, BD, and CD on the sketch were determined to be 1,800 feet, 1,400 feet, which is EB, so that's this one, 700 feet, that's BD, and 800 feet, respectively. So AB, EB, BD, and CD. Oh, whoops. I messed up. That last one should be here, 800. And segments AC and D intersect at B. And angle AEB, which is this one, is the same thing as angle BDC, or CBD. What is the value of x? So if we look at these triangles, what we can notice is that they share an angle here and here, and this side is half of that side, which means basically these are similar triangles, meaning they have the same angles. We also know that this is going to be the same thing as this, because anytime lines cross, we have this angle is the same as this angle. That's known as a vertical pair, which is a common geometry idea we'll use in these problems. So basically, if this angle is the same thing as this angle, and that one's the same as that angle, then it must be the case that these are similar triangles, which means that this side is going to be half of that side. So we can just multiply 800 by 2 and get 1,600, and that's our answer. Okay, the last topic we're going to look at today is parallel lines. So if we look at this diagram, it tells us in the figure above, lines L, this one, lines M are parallel. So this is parallel to that. If the measures of 1 is 35, what is the measure of 2? 2 being this angle and 1 being this angle. So whenever we have parallel lines, we also know this one S and this one T are parallel. So basically we have 4 intersecting parallel lines, or rather 2 pairs of intersecting lines. It's going to be the case, like I just mentioned in the last one, that these 2 angles are going to be the same always, and these 2 angles are going to be the same in a pair of intersecting lines. And we know that this angle here is going to be the same as angle 1 because lines L and M are parallel. Similarly, this angle here is going to be the same as that angle 1. So basically what we have is we know there's a line here where there's 1 and there's 2. And 1 we were told is 35 degrees. So if this is a straight line though, this line that 1 and 2 are on, then angle 1 plus angle 2 must be equal to 180. So if angle 1 is 35, well that plus angle 2 is equal to 180, which means we can subtract 35 from 180 and get angle 2 is equal to 180 minus 35, which would be the same thing as 145, which is option choice D.